This video covers section 5.6, factoring trinomials. Our goal in this section is to learn to factor trinomials by Let's get warmed up by multiplying 2x minus 3 by x plus 5. Start by using the FOIL method. 2x multiplied by x is 2x squared. 2x multiplied by 5 is 10x. Negative 3 multiplied by x is negative 3x. And negative 3 multiplied by positive 5 is negative 5. The next step is to combine like terms to get our final answer. When we combine the 10x and the negative 3x, we get a 7x. So our final answer is 2x squared plus 7x minus 5. Now, these two are equivalent expressions. 2x squared plus 7x minus 5 is the same thing as 2x minus 3 multiplied by x plus 5. If you plug in a 2 or a 7 or a negative 35 into x over on this side, you'll get the same thing as if you plugged it in over on this side. These two expressions mean the same thing. They just look a little bit different. So which one do you think is the factored form? Remember that factoring means to write something as a product, so there's multiplication involved. If you guessed that the 2x minus 3 multiplied by x plus 5 is the factored form, then you were correct. Our goal in this section is going to be to start with trinomials like this one, 2x squared plus 7x minus 5, and factor them like this, 2x minus 3 times x plus 5. We're going to be unmultiplying or unfoiling. We're going to be spending a lot of time undoing the FOIL process. So let's go ahead and multiply this out again and just pay really close attention to what happens and where everything goes. First, I multiply 2x by x, and that's what gets me my x squared term at the beginning. Then I multiply 2x by 5. So I have a 2x multiplied by a 5. Then I multiply negative 3 by x. So there's my negative 3 multiplied by x. And finally, I do negative 3 multiplied by 5. I'm going to do that multiplication now, which gives me 2x squared plus 10x minus 3x minus 15. The last thing I always do is combine like terms. These two middle terms always seem to be the ones that get combined. So I end up with 2x squared plus 7x minus 15. Now let's see what we can do to think our way through that process backwards. I have 2x squared minus 5x minus 3. And I'm going to try to make a good guess about how it should factor. I know that I'm going to need two sets of parentheses here, and I'm going to need to be filling in 4 slots, here, 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 and here, to make it look something like this up here. Now, the x's always seem to go in those first slots, so let's just go ahead and fill them in to give ourselves a place to start with. My x squared term up here came from multiplying my first 2 terms together. Here I also have a 2x squared. If I multiplied now, I would have x multiplied by x, which is just x squared, but I need 2x squared. So I'm going to put a 2 in front of the x there. Another thing that I noticed is that my last term, the constant term, came from multiplying these last 2 terms together. I need to multiply 2 things together to get negative 3. So it's going to have to be 1 and negative 3, or negative 1 and positive 3, but I don't know which spot it should go in. Finally, I noticed that my middle term came from first multiplying my outside and inside terms together and then adding. Let's see if we can do a little bit of guess and check to make this work. So I'm going to just kind of blindly put a negative 3 here and a positive 1 here and see what happens when I multiply it back out. See if I got what I wanted. When I multiply my first 2 terms, I get 2x squared. When I multiply my outside terms, I get a plus 2x. When I multiply my inside terms, I get a minus 3x. And when I multiply my last terms, I get a negative 3. Well, this isn't quite going to work. When I combine my like terms, I'm going to get 2x squared minus x minus 3, which is not what I started with. So I know that this is not a correct factorization. But what went wrong? It seems like my 2 middle terms didn't add up correctly. So let's try this again. I'm still got my 2x and my x in the right spot, those multiplied together to give me 2x squared. What if this time I put a negative 3 over here and a positive 1 over here? Then what will happen? I start multiplying these together, and I get 2x squared minus 6x plus x minus 3. Now when I combine those two middle terms, I'm going to get a negative 5x. And that is what I started with, which means that this is the correct factorization. Factoring by guess and check is a perfectly valid method, but it can take some time and it can get kind of frustrating if you're not getting things to work out. So instead, I'm going to show you a systematic method that will work every time to factor these trinomials. We're going to work through this method first using an example. We're going to work on factoring 4x squared plus 17x plus 4. The first thing that we'll do is find two numbers that multiply together to be the same as a multiplied by c, but add together to be b. Here's what I mean. A times c, in this case, is 4 times 4, which is 16. And b is 17. I would like to find two numbers that multiply together to be 16, but add together to be 17. We can just start listing factors of 16 until we get something that works. The first factor of 16 is 1 and 16. Well, hey, there's one that works already. 1 plus 16 is 17. So there are my two magic numbers. Now that I've found those two numbers, I'm going to rewrite my original expression using these numbers. I'm going to uncombine the middle term. I'm going to write this as 4x squared plus 1x plus 16x plus 4. So notice I haven't really done anything to it except that I took that 17x and split it up into a single x and a 16x. Now that we've done the first step to uncombine that middle term, we can factor by grouping. I have a 4x squared plus an x and another group that is 16x plus 4. When I look at my first two terms here, they have an x in common, so I'll factor the x out, which leaves me with 4x plus 1. In my second group, I see that these two terms have a 4 in common, so I'm going to factor a 4 out, which leaves me again with 4x plus 1. Now I've got two terms, x times 4x plus 1 plus 4 times 4x plus 1, so they both have a 4x plus 1 in common. I'll pull that 4x plus 1 out and leave behind an x from the first term and a 4 from the second term. And that is my factorization. I'd like to go ahead and check our answer, and while we're at it, we'll think about the factoring process. So I got 4x plus 1 multiplied by x plus 4. When I start multiplying this out, I get 4x multiplied by x is 4x squared. Then my outside terms give me a plus 16x and then a plus 1x. And then finally, my last term gives me a plus 4. Notice that now we're back at this spot where we uncombined like terms. In order to finish simplifying this, we're going to combine these two terms to get that 17x. 4x squared plus 17x plus 4, which sure enough is the thing that we started with. Probably the most tricky part of this process to convince yourself of is why we need to find numbers that multiply together to be a times c, but add together to be b. So let's look a little closer at that. We need those two numbers, whatever they are, to add together to be b, our middle term, so that when we're combining like terms over here, we get two things that add together to be the original middle term. To help convince you of why we need to look at factors of a times c, I want to take you back to our guess and check example that we did earlier. In this example, we knew that we needed things that multiplied together to be 2 and also things that multiplied together to be 3. In other words, we needed factors of a and also factors of c. We just didn't know which order to put them in. Back over here, by looking for all the possible factors of a times c, we're basically exploring every single possible combination that might work ahead of time without having to do all the guess and check. Okay, that's enough talk about why the method works. Let's just do some examples. My first example is 6x squared minus 13x plus 6. So remember that I'm going to start by looking for factors of a times c. And by a, I mean the lead coefficient, And by C, I mean the last term over here. So in this case, I have 6 times 6, which is 36. And then I'm looking for things that multiply to be 36, but add up to be B, which is negative 13. Sometimes students like to make this little diagram to keep their thoughts organized. So we're going to put the 36 up here and the negative 13 down here. I need to fill in the two sides with numbers that multiply to be 36, but add to be negative 13. Now, if nothing jumps out at you right away, that's okay. The first thing I'd like you to do is notice that if two things are going to multiply together to be a positive number, but add together to be a negative number, we're going to need them both to be negative. Now that we know that, let's just start writing down all of the possible ways to factor 36. I could have 1 and 36, 2 and 18, 3 and 12. What else have I got? 4 and 9. Oh, this is starting to look promising. Negative 4 and negative 9 multiply together to be negative 36, but they add together to be negative 13. That looks like our magic numbers, negative 4 and negative 9. Now that we have those two numbers, we can use them to uncombine the middle term of our trinomial here, rewriting it as 6x squared minus 4x minus 9x plus 6. Now we're going to factor by grouping. I'll go ahead and group my first two terms together. So I have 6x squared minus 4x in a group, and then my next terms will be negative 9x plus 6 in a group. Now I look at my first two terms and see if they have anything in common that I can factor out. I see that they have a 2 and an x. So I'm going to factor out a 2x. That leaves me with a 3x and a negative 2. Now I go ahead and look at my second terms, negative 9x plus 6. Here I'd like to give you a tip about factoring by grouping and negative signs. If you have a negative on the first term in your group, always factor out a negative if you can. So here I have negative 9x plus 6. The 9 and the 6 certainly have a 3 in common, so I'm going to factor out a negative 3. Negative 9, factoring out a negative 3, leaves me with a positive 3x. Now, if I factor a negative 3 out of positive 6, I need a negative 2 left over here. You can convince yourself by thinking about what you need to do to multiply this negative 3 back through. Negative 3 by positive 3 will give me that negative 9, but I need a negative 2 here to get negative 3 times something to be positive 6. Now, just take a step back and see if anything good has happened. I have 2x multiplied by 3x minus 2. And I have negative 3 multiplied by 3x minus 2. So I can factor out that 3x minus 2 from both terms. The first term leaves me with a 2x, and the second term leaves behind a negative 3. So there is my final answer for that factorization. I'm going to leave it to you to multiply that back out and verify that this is actually the correct factorization. Well, we move on to the second example. My second example is 14x squared plus 29x plus 12. So I start with my same method as before, trying to figure out what is a times c. In this case, my a is 14 and my c is 12. 14 times 12 is 168. My b is positive 29. So over here in my little diagram, I'm looking for two things that multiply together to be 168, but add together to be positive 29. Now, I don't know the factors of 168 off the top of my head, and I certainly can't come up with two that add up to 29 without really thinking about it. So what I want to do is go through this systematic method of writing down all the factors of 168 until we find the ones that are going to work. We start with 1 and 168. Well, those aren't going to add up to 29. So now I go 168, and I'm going to divide it by 2 to find out that 2 and 84 are two factors of 168. Next I'll try 3. Is 168 divisible by 3? Sure enough. 3 and 56 are factors of 168. Then I try 4. 168 divided by 4. Hey, that works out too. Now I've got 4 and 42. Next I might go up to 5, except that I know by looking at it that 168 is not divisible by 5, so maybe I'll try 6. 168 divided by 6 is 28, so now I've got a 6 and a 28. Then we'll try 7. 168 divided by 7 is 24. What about 8? Will 8 go into it? 168 divided by 8 is 21. 8 and 21. Oh, and now I could keep going, but I see that 8 and 21 will work. They add up to be 29. So there are my two magic numbers. Now that I have my two numbers, I use them to uncombine that middle term, making this 14x squared plus 8x plus 21x plus 12. Now that I've uncombined that middle term, I'll go ahead and group my terms up. My first two are 14x squared plus 8x, and my last two are 21x plus 12. And now I start looking at my first group to see what they have in common. In 14x squared plus 8x, I see that there's a 2x in both of them, so I factor that out. When I take a 2x out of 14x squared, I get a 7x, and when I take a 2x out of 8, I get a plus 4. Now I move on and look at my second term. I've got a 21x plus 12, and the only thing that I see in common there is a 3. So I'm going to factor out a 3. When I take a 3 out of 21x, I'm left with 7x, and when I take out a 3 from 12, I'm left with 4. Now I step back, look at what I have. I have 2x multiplied by 7x plus 4, and 3 multiplied by 7x plus 4, which means that that 7x plus 4 is in both of them, so I can factor it out, and I'm left with a 2x from the first term and a 3 from the second term. So there is my final answer for that one. Okay, now it's your turn to try factoring a couple of trinomials. So go ahead and pause the video, try factoring these, and then when you resume, we'll talk about them together. And we're back. Now in this first example, my a multiplied by c was 5 multiplied by negative 6, giving me negative 30, and my b is 13. So I'm looking for two numbers that multiply together to be negative 30, but add together to be 13. Because they need to multiply together to be negative 30, one will have to be positive, and one will have to be negative. Also, since they have to add together to be a positive number, I know that the smaller number will have to be the negative one. So I just start writing down factors of negative 30 with one of them being negative. Negative 1 times 30, negative 2 times 15. That one will work. Negative 2 plus 15 is positive 13. So there's my two magic numbers, negative 2 and positive 15. Now I use those to rewrite my middle term so that I have 5x squared minus 2x plus 15x minus 6. Now I factor by grouping. So I group my first two terms together, 5x squared minus 2x, and my last two terms together, 15x minus 6. Now I look to see what they have in common. Between 5x squared and negative 2x, I can factor out an x, leaving me with 5x minus 2. And between 15x and negative 6, I can factor out a 3, leaving me with 5x and negative 2. Now both of my terms here have a 5x minus 2, so I can pull that all the way out, giving me 5x minus 2 multiplied by x plus 3. In my second example, a times c was 14 times negative 3, which came out to be negative 42, and my b is negative 1. So I'm looking for two things that multiply together to be negative 42, but add together to be negative 1. So some things that I noticed before I even start that process is that in order to multiply together to be negative 42, one of my two numbers will need to be negative. And in order to add together to be a negative number, the larger number is going to have to be the negative number. So I start writing down factors of 42. I started with negative 1 times 42, but realized quickly that that definitely wasn't going to work. Then I have 2 times negative 21, 3 times negative 41, 4 and 5 don't go into 42. So my next up is 6 and negative 7, and here's the ones that work. 6 times negative 7 is negative 42, and 6 plus negative 7 is negative 1. So I use those two numbers to rewrite my middle term so that my polynomial is now 14x squared plus 6x minus 7x minus 3. And then I group my terms, so I have 14x squared plus 6x and negative 7x minus 3, From my first two terms, I can pull out a 2x, which leaves behind a 7x and a 3. For my second two terms, they're both negative. So a good tip here is to always pull out the negative if your term at the beginning is negative. So I pull out -1, which leaves me with 7x plus 3. Now both of my pieces have a 7x plus 3, and when I take that out, I'm left with a 2x from the first term and a -1 from the second. Before we do a couple more examples, I want to remind you that what order you write these two numbers down in doesn't matter. If you write 14x squared minus 7x plus 6x minus 3 and then factor by grouping, you will still get the same thing in the end. So don't worry about which order you need to write those two numbers down in. Now I have a couple more examples just to get us some more practice. Let's look at factoring x squared plus 9x plus 18. I start by figuring out what a times c is. In this case, a is 1 and c is 18, so I'm going to end up with 18, and my b is 9. So I'm looking for things that multiply together to be 18, but add together to be 9. And as I start going through the list of factors for 18 in my head, I see that 3 and 6 will work. 3 and 6 multiply together to be 18, but add together to be 9. Now I can use those two numbers to rewrite my middle term, making this x squared plus 3x plus 6x plus 18, and then doing my factoring by grouping. So I'm going to group my first two terms together and my last two terms together. From my first two terms, I can pull out an x, leaving behind an x plus 3, and from my last two terms, I can pull out a 6, also leaving behind an x plus 3. Now I can pull that x plus 3 out, leaving behind an x plus 6. Did you notice that down here we ended up with x plus 3 multiplied by x plus 6, and those were the two numbers that we started with from up here? That's going to happen whenever the value of a is just 1. When you factor a times c, you'll really be factoring just c, looking for numbers that multiply together to be c, but add together to be b, and those two numbers will always be what you end up with down in your final factorization. However, that only works when the value of a is 1, so be careful about using that shortcut. Now let's go ahead and look at this next example. I have 2x squared plus 6x plus 4, so a times c is 2 times 4, which is 8, and b is 6. So I'm looking for two numbers that multiply together to be 8, but add together to be 6. And in this case, with such nice small numbers, I can see what those two numbers will be without having to go through all the possible factors of 8. It looks to me like it's going to need to be 2 and 4, since those two multiply together to be 8, but add together to be 6. Now I can use those to split up my middle term, making this 2x squared plus 2x plus 4x plus 4. And now I can factor by grouping. I'm going to group my first two terms together and then group my last two terms together. From my first two terms, I can factor out a 2x, which leaves behind an x and a 1. Don't forget that nice placeholder 1. And from my last two terms, I can factor out a 4, which again leaves behind an x plus 1. And finally, I can pull out that x plus 1, leaving behind a 2x and a 4. And remember that you could always check that factorization by multiplying it back out and making sure that you get what you started with. And now I've got a couple of problems for you to try. Here's one where the value of a is just 1, so you may be able to try using that shortcut. And here's one where you're going to need to factor out the greatest common factor first, and then factor what you're left with. So go ahead and pause the video, give those a try, and then when we come back, we'll talk about them together. And we're back. So my first example was x squared plus 9x plus 20. So a times c is 1 times 20, which is just 20. b is 9. So we're looking for things that multiply together to be 20, but add together to be 9. 4 and 5 will do the trick. I decided to go ahead and go the long route and split my 9x up into 4x and 5x, and then factor by grouping. So from the first group, I factored out an x, which left me with x plus 4. From my second group, I factored out a 5, which left me with x plus 4. Pull out that whole x plus 4, and I'm left with x plus 4 multiplied by x plus 5. My second example is x squared y squared plus 4x y squared plus 3y squared. And in this case, we want to start by factoring out the greatest common factor. The greatest common factor here is y squared, since each term has a y squared in common. So I factor out the y squared, leaving behind x squared, 4x, and 3. Now I have something that I can factor nicely, x squared plus 4x plus 3. A times c, 1 times 3, is just 3, and b is 4. So I'm looking for things that multiply together to be 3, but add together to be 4. 1 and 3 are the numbers that'll do the trick. So ultimately, once I factor x squared plus 4x plus 3, I'll end up with x plus 1 multiplied by x plus 3. The big trick on this problem is not forgetting to leave that y squared as part of your factorization. For me, I usually carry that greatest common factor down along with me through the whole problem, otherwise I'm likely to forget to put it there at the end. But our original problem had a y squared in it, which means that my ultimate factorization still needs to have that y squared. Remember, if I were to check my answer, I would multiply this out and then multiply that y squared back through, and I should end up with what I started with. That means that anything that I factor out needs to be in my final answer. Finally, I want to show you that some trinomials are prime and just can't be factored nicely. So for this example, we're going to show that this trinomial is prime by trying to factor it and seeing what goes wrong. So here I have x squared plus 3x plus 6. So a times c is 1 times 6, which is 6, and b is 3. So I'm looking for numbers that multiply together to be 6, but add together to be 3. So let's start listing all the numbers that multiply together to be 6. There's 1 and 6. There's 2 and 3. I could write down 3 and 2, but I've already written down that pair, so I really don't need to. And because I've been going systematically like this, 1, 2, 3, as soon as I hit a repeat pair, I know that I've written down all of the possible pairs. So now I start looking at my factor pairs and seeing if any of them add up to 3. 1 and 6 sure don't work, neither do 2 and 3, and that was all my pairs. That means that there just aren't any numbers that multiply together to be 6, but add together to be 3. We've exhausted all of the possibilities. That tells us that this polynomial doesn't factor nicely, which makes it a prime polynomial. If you get to a problem like this in your homework or on a test, once you've tried all the possibilities, you can go ahead and write down that it's prime and can't be factored. That wraps it up for section 5.6. Good luck with your homework.